In this problem, we are asked to solve equations algebraically, write our answers in exact form, then give the decimal approximation rounded to the nearest hundredth. We're also asked to be sure to check our final result. These are radical equations. The first one is a cube root. That's what the 3 is right here. So to undo a cube root, what we are going to do is raise both sides of the equation to the third power. I'm just going to put parentheses, third power. So the cube root and the cube undo each other, and I just get 2x minus 1 equals, now I need to raise 5 to the third power, so that if I come over here, 5 times 5 is 25, times 5 is 125. Now I need to solve for x. I'm going to add 1 to both sides, so I get 2x equals 126. Divide both sides by 2. I'm going to get x equals 63. Now it's very, very important for any radical equation that I solve algebraically that I check my result. And what that means is to take the value for x that I solved for, plug it into the original equation, and be sure that I obtain a true statement. So let me take the 63 and replace the x under the radical. So I have the cube root of 2 times 63 is 126 minus 1. That's going to be equal cube root of 125. So what times itself 3 times gives me 125? Well, we know from our work up here, 5 cubed is 125. So the cube root of 125 is 5. And that checks with our original equation that we were given. So our solution then for part A is x equals 63. Now let's move over to part B. We have a different kind of radical equation. The radical part is here. So I'm going to want to begin by subtracting 41 from both sides. I want to isolate the radical part of my equation. If I do that, I get 5 times the square root 2x minus 4 equals negative 30. And right away I see, if I'm really paying attention here, that there may be some kind of a problem, because I'm seeing 5 times the square root of some result giving me a negative number, and that is not going to work for us. But let's see how that manifests itself as we work through the solution. Now I'm going to divide both sides by 5, so that gives me the square root of 2x minus 4 equals negative 6. To undo a square root, I'm going to square both sides. That gives me 2x minus 4 equals negative 6 times negative 6 is positive 36. 2x equals, I'm going to add 4 to both sides, give me 40. Divide both sides by 2, I get x equals 20. Now let's see what happens with our check. Again, very, very important that we check. I'm going to take x equals 20, plug it into the left-hand side of the equation, and see if I come up with the value on the right-hand side. So this is a square root. 2 times 20 minus 4. So I get 41, and that equals, plus 5 times the square root. 2 times 20 is 40 minus 4, that's 36. So I get 41 plus 5 times square root of 36 is 6. I get 41 plus 30, and that is 71, which is not equal to 11 as we were given in our initial statement, meaning that x equals 20 is not a solution. We actually call it an extraneous solution, meaning kind of a fake solution. So we found by checking then that we have no value of x that will give us 11 here, so we have no solution to the original equation.